Yeah, 2 hours of nothingness. So just like we can graph all of our exponential functions with different bases, you need to learn how to graph every single log function with different bases. So these will be our parent graphs. The first thing that you're going to know about every single log graph is that if every single exponential graph has the point 0, 1, every log graph will have the point 1, 0. And if your exponential graph had 1, 4 for a 4 to the x, your inverse is going to have 4, 1. So whatever the base is of your log, you're going to have that point, 1, because if you think of, well, what is log 4 of 4? You're basically asking 4 to what power is 4? And the answer is 1. So we have the point 4, 1. All log graphs, all your parent graphs, will have an asymptote at x equals 0. So with all of these things together, now we can draw your basic log graph, which looks like an exponential graph kind of turned. So identify the intercepts. There is only an x-intercept of 1. The equations of the asymptotes, well, our asymptotes equation is x equals 0. The domain is your x values are greater than 0, and your range is everything. Yes? Well, we get 1, 0 and 4, 1 because if you thought about y equals 4 to the x, right? A graph you already know. It has 0, 1, and 1, 4. So when you do the log, which is the inverse, all of your points are going to get switched. So what you're going to have going forward is you're just going to know that just like you know that all your exponentials have 0, 1, all of your parent graphs of your log graphs are going to have 1, 0. And then the 4, 1, you can also get by saying to yourself, what are values that I know that I could plug in? I know that 4 to the power 1 is 4. Sorry, 4 to the power of 1 is 4. Yeah, that's right. So log 4 of 4 is equal to 1. What's another point I could put on here? (16,2). Because log 4 of 16 is 2. Now do you still have room at the bottom of page 378? Some of you might. Just in that big white space at the bottom? Okay. Right there, we're going to graph this one. So first of all, we already learned that there's a common log. And so when you write this, what's the base? 10. So we should write that in again. Right? This has a hidden base of 10. I was going to write that in white, but my white pen apparently is not working. Maybe I need to recalibrate, but it looks like it's calibrated pretty good. Yeah, it's okay. Anyways, this one is the natural log. The L and the N stand for natural log. L for natural, N for log. And no, I think it's probably French. logarithm naturel, something like that. And the natural log has a hidden base that's not written either, and it's e. So really, ln of x is the same as writing log with an e of x. But instead of having to write all these extra letters, look how much time you're going to save by writing ln instead of log base e of x. Oh, no, two. Look at this and that. So much time saving. Okay. So when we go to graph it, what point is on every single log graph? 1, 0. And on this one, we're going to have what comma 1? E comma 1. It will still have an asymptote here at x equals 0, and the shape is still the same shape as our other log graphs. Questions you can do are 10 and 11.